Hi, welcome to question 10 of the 2023 Paper 2 Leaving Cert Ordinary Level. So as always, if you want to copy the notes I'm working off, just send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. So we're here on question 10 and it's trigonometry, I guess. Um, yeah, trigonometry. So it's a 10 marker and it says a toy company makes spinners in the shape of a regular pentagon. Now, pentagon means five-sided. So, like, if I wasn't sure of what to do, pentagon equals five sides. That might be enough to get work of merit. I don't know. It's a bit little, but although it does say any correct geometrical interpretation worked or indicated on diagram. So maybe if you put 1, 2, 3, 4, 5, and it'd be you have to see what the interpretation of the grader is. Each of the five sides, oh, they do say five, so maybe not, of the pentagon ABCDE is the same length. Okay, so actually this would do it. They do tell you the same length, but you're showing that you understand what that terminology means. The pentagon is divided into five congruent, okay, that means they're the same, isosceles triangles. So an isosceles triangle means these are all of equal lengths. Okay, so if you're indicating that, again, that's another piece of knowledge. Now you're kind of given it, but whatever. The angle BOC is 72 now, definitely. If you wrote in 72 here, okay, they're all 72. Now every angle here will be equal to. So again, there's different ways of expressing the information in this particular diagram. And even actually writing 6 here, because that again is showing it. Now I'm clouding up the diagram here. The problem with something like this is sometimes if you do wrong things on it, it's very hard to unsee the wrongness. Maybe if you're drawing a diagram, do it in pencil, although they do recommend using a pen. But a good HB pencil, the scanners will pick up. Okay. Now it says in part A, work out the angle CBA, the size of the angle. Just restating it. So this is just the terminology. This means that the magnitude of, and this means the angle, and the middle one is what matters. So they're working out CBA. Okay. Um, Now, CBA would be this bit here and this bit here. So if I know this bit here, well, then I can just double it. Okay. So in that triangle there, now I could draw it just to illustrate for myself. Okay. This is 72. It's an isosceles. So these two angles must be equal because it's an isosceles. So 180 degrees is equal to all the angles in a triangle, and that's equal to 72 plus, now I'm going to call it A, plus A, because the two angles are the same, so they're both the same letter. Now, this is an equation of one unknown. Okay, so I can simplify it by adding the A's. You get 2A. Now, if I want to get rid of the 72, there's different ways of doing it, but I could take 72 away from it. That'll achieve it. 72, take away 72 is gone. But if I do it to one side, and I can do whatever I want to in the equation, I must do the same thing to everything on the other side. Then it's the balance is there. So 180 take away 72 is 108. Yeah, 108 is equal to 2A. Now I could simplify that and get, what was it, 54 is equal to A, okay? But if that's 54, that's 54, that's 54, they're all 54. So what are these two together? Well, it's 54 plus 54, which is the 108 degrees. Okay, so in the answer, I've that done now. Did I finish it off? CBA, actually I got this wrong because I declared the answer as 54. And maybe they would have given it there. I'd be interested to see now what happened there. If I saw this, because this is A here as well, you'd have to have a think about that. If the work was all perfect and the logic was shown, that the right none was there, I probably would give it, to be honest. But as it stands, I wouldn't be perfectly happy with it. I've just misinterpreted or I forgot to do it or whatever. Now, part B there says, work out the area of the triangle AOB. So now we know that this is 54. We know that this is 6. We know that this is 54. And this is 72. So look, I definitely have the attempt right there. And all of these parts would came off the original diagram. So any markings on the diagram have to be assessed or should be assessed by the grader for, is it like a logical progression of thought? Now, the area of a triangle formulas are, I suppose there's a few of them, but the one that you might be more familiar with is a half base times height, which generally works with 90-degree triangles. Okay. Now, the other one, and you'll see this in the book, is a half AB sine C. Now, this is the triangle AOB. So if I was to draw it out, okay, we said that was 72. This is 6. This is 6. Now, this is 54 and 54, okay, which doesn't actually matter. But I could use like the sine rule to find out the length of this side AB. But we're being asked the area. But the area formula here works if you know an angle. So I'm going to call this angle C. And the two sides either side of it, well, then you can calculate the area of that triangle. Okay, so if I put those numbers in, now I have it done here on the page, it's a half times 6 times 6, because both A and B are 6, times sine 72. I put that through my calculator, and I got 17.119. Now, I should use the answer on the calculator, but it's asking for and hence, I should have read the question, hence work out the area of the pentagon. So there's 5 triangles within the pentagon. I know the area of one, so I just have to multiply it by 5. And I should not round my answer before I multiply by 5. Otherwise, there'll be a potential of a rounding penalty, for the simple reason that your answer, if rounded early, is less accurate than it could have been. And that's where the rounding penalty comes in. Right, that's a 10 marker. So, I mean, going into the exam, we should know how to use some of the more basic formulas in trigonometry. Now, the half base by height is probably the basic one. So an intermediate one would be a half AB sine C. It's going to come up. So it's just to recognize when it's being asked and then which strategy to employ. And that's ultimately what maths is. It's a whole pile of different strategies. Now, some people are better at remembering those strategies or developing those strategies. The rest of us, okay, have to slog through and learn them off, okay? And then you have to try recognize the situation, then which strategy to use, and then how to use the strategy, and then present your answer, okay? Now, if you think about it, that's a great skill to have. So if you can demonstrate that skill and get a good grade in maths, I'd always be referring to that in an interview. Go, look, I've done well in maths, and that shows that I have a certain type of thinking, which I think can bring value to your company, blah, 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 pay me money. Anyway, that's part B. So part C, part 1, the triangles in the spinner are numbered 1 to 5. So we're moving into probability here, okay? The spinner is spun twice, okay? And each number landed on is recorded. It says write down a sample space to show all of the 25 possible outcomes when the spinner is spun twice. Okay, they're very helpful nowadays. It may be useful to draw a two-way table or to list the outcomes in a systematic way. And I was literally about to say that. My issue with these questions is that when I'm not organized, I end up either doing the same one twice or whatever. I just get all disorganized. Now, practice makes perfect. So let's look at the answer. Now, I suppose the logic would be that I could have a 1 on the spinner, a 2, a 3, a 4, or a 5. Now, if I spun it a second time, I could have a 1, a 2, a 3, a 4, or a 5. So on my first spin, or first 2 spins rather, I could have got a 1 and a 1. Okay. Now, if I went again, okay, or a different version of me in the multiverse, whatever, I could have got a 1 and then a 2. And another version of me could have got a 1 and a 3, a 1 and a 4, a 1 and a 5. Or I could have got a 2 first, and then a 1 or a 2 or a 3 or a 4 or a 5. I hope you get the logic. Now, again, this is the logic of maths, okay, and this is tricky, but being good at this shows that you are capable of this type of thinking, okay. And it is a skill you train. So I'm not very good at that because I'm not very good at being systematic, okay. But I've learned the strategy for this particular question, and it's very easy, especially for a 10 marker, if you know what you're doing. It's just a matter of getting it done, okay. Now it says the spinner is spun twice and the two numbers are added. What are the maximum and minimum possible totals when two numbers on the spinner are added. Now, this is actually really easy. Now, whatever you declared in part one, so whatever answer you got, okay, is going to be accepted as correct. So if you couldn't get part one or whatever you did, even if it was incorrect, as long as you do this next part right, you're gravy. Okay. So the minimum, like if I add a one and a one, I get two. Okay. If I add a one and a two, I get three. A one and a three, I get four. A one and a four, I get five. A one and a five, I get six. Now just keep going. You're gonna see pattern. Okay. Down here, 5 and 5 is 10. So once you see all the numbers, if you go that far, if you don't realize it already, well, the minimum one, the smallest I can get is 2. Okay. The biggest I can get is 5 and 5 is 10. And that's it. Handy 5 marks. Okay. If you can read and understand what the question is asking. I find with probability and to a certain extent statistics, when I don't read the question carefully, I can do all sorts of stuff. Okay. And I've seen this any number of times teaching where I've been stuck on a problem and getting the wrong answer. And I'm like, oh, the book is wrong, but the book isn't wrong. Okay, it's me. And then sometimes I go home and I read the question and I go, oh God, I just didn't read. One word can change the meaning. Okay, and that is a problem with probability. It is what probability is. It's counterintuitive sometimes. So people can make all sorts of mistakes, which is why it's something that needs training. But sometimes it's not complicated. Okay, and something like spinners like this, if you just if you can imagine in your head, in any way, even like, then that imagination can help you to figure out a strategy. So they can be great questions, especially for getting attempts. Be trying something. Okay, never leave a blank space in probability. Multiply two numbers, do whatever. It's usually multiply or add. If your answer is bigger than 1, it's wrong. If your answer is negative, it's wrong. And pick the option that has an answer between 0 and 1 when it's in decimal form. Okay, so now he says each time the spinner is spun, each number 1 to 5 is equally likely. Now, fair enough. Okay, it's not a trick spinner, and spinners can be weighted. When you get into the trickery of probability, and maybe you've bought one in a joke shop, like a weighted coin that will fall heavy side down more often, or the dice is loaded and maybe they've drilled a hole on one side and put heavier paint in to make it more likely to land heavy side down. And even if that probability is only like 1 in 10, it lands more often. If you're betting over time, you will win money. And that's, I'm not saying that's how casinos work because that's probably slanderous, but dodgy casinos would work that way. And any of the other number of ways they do to get the odds in their favor or more in their favor. So it says each time the spinner is spun, each number 1 to 5 is equally likely. Work out the probability of getting a total of either 4 or 5 when the two numbers are added. So again with part 3, whatever answer you declared in part 2, they have to interpret that new information, even if it's totally off the wall. Okay. So I always attempt just work off your last answer. Now this is the answer, but I'm adding up all or just counting up all the ones that add to give 4 or 5. So I've highlighted them here. 1 and 3 is 4. 1 and 4 is 5. Now 1 and 5 is 6, so that's not included. 2 and 1 is 3. No. 2 and 2 is 4. Yeah. 2 and 3 is 5. So you see the ones that are highlighted. Okay. Now it's saying what's the total number of outcomes. Okay. So the probability can be scored by the number of things that do happen divided by the number of things that can happen. Now 25 things can happen. Okay. 7 of them add up to 5. So you can, now I didn't display that as a decimal. I don't think the marking scheme particularly cares. 10C part 3. Now they give it as a fraction, a percentage, and as a decimal. And yeah, they don't care. So part D here is a 10 marker. Now this is in a different spinner. There are 4 different outcomes. Oh yes, brilliant. I think this is the last question on the paper. Yeah. So we're going to end on a strong point. North, south, east, and west. It says, in a game, Jenna pays €1 to spin this spinner. The table below shows the probability of each outcome as well as the money Jenna will get, depending on the outcome. So if she gets an N, there's a probability. So these are all different sizes. That's why there's different probabilities. If these were like an equal divided spinner, like then you'd have 0.25, 0.25, 0.25, 0.25. But this is not. So these are different sizes, and you could probably work out the sizes of them if you were asked. So the one most likely to win is 0.4 E, but if E lands, you get nothing. Okay, so the bigger of the divisions. Okay, then the one where you make the most only has like 0.1 or a 10% chance or 1 in 10 chance. So that's the smallest sliver. Okay, and then you have two intermediates. You get your money back in this second biggest one, and you get half the money back if you land on this estimate, which is like 1/5 of it, 2/10 of it, 1/5. Now it says, is this game fair? Justify your answer. Jesus, um, that's a loaded question. So I was going to check the marking scheme. So I just paused there to check the marking scheme, and it doesn't really say it. It does say it's not a fair game, and I'll show you why they would justify it. But I wonder, I didn't mark it that year, or last year. So, I mean, if you said the game is fair because the casino has to make money, I don't see how they'd argue against that. Like they have to pay their staff or something. I'd love to know actually. But the answer now, the expected value is a calculation. It's given here, okay? So it's the sum of the data multiplied by the probability. So really all that means is, okay, you have here the first one is 1 times 0.3. Okay. Now sum means plus, so add. So it really, I should put brackets here actually. Yeah, I should put brackets here. Your money or the data is 1 times 0.3 plus 0.5 times 0.2 plus 0 times 0.4. Now that'll be 0, okay, in the calculators, but you could not include it, but I should include it just to follow the pattern. And then it's 5 times 0.1. Now, when you put that through the calculator, you get 9/10, or your expected winnings would be 0.9 over the longer term. Now, is that fair? No, because you're definitely going to lose money. You're paying a euro, but only expected to win 0.9. So if you do 100 spins, you might pay 100 to play and win 90. Okay, or do 1,000, you'll spend 1,000, win 900, and that's gambling. Okay. Now you could be lucky and get like 4 or 5s in a row in that 100 or that 1,000 spins, but over the longer term, probability always wins out, and that's really what all expected value is. So that's how casinos work. And there's a thing like in critical thinking called the gambler's fallacy, and in short, it's where people are on a losing streak will think, "Oh, I've been losing. I have to win big." Now, if it's an independent event each time, then no. I mean, next spin doesn't have to be a win. It's still the probability. Or people think I've been winning, so I'm on a streak. So I'm going to start betting higher and higher and higher.